distributed messaging system called Kafka, and later on it's open source. Now it's part of the Apache Foundation. So how many people here have heard about Kafka? I think about like a third. Okay. So what Kafka is, it's sort of a distributed messaging system. And it differs from a lot of traditional messages in just two ways. The first one is its throughput. Basically, with Kafka, you can flow messages in a number that's easily 100 times or 1,000 times bigger than you can flow through a traditional messaging system in typical or ActiveMQ. The reason why we did that is the kind of data that we are collecting through Kafka is a lot more diverse than the traditional data. So at LinkedIn, in the end, we have all the business metrics, like page views, impressions, flowing through our system. We have all the operational metrics, like all the GMS, all the IO stats flowing through our system. We have all the service logs, like Apache log and then log4j log. We have also all the database data flowing through our system. So this is actually a very, in terms of volume, this data is easily a lot, maybe 100 times, 1,000 times bigger than it would typically flow through a typical ActiveMQ messaging system. And what it gives you is a very powerful, essentially data hub, where you can collect all kinds of data. And a second difference of our system with traditional messaging system is the kind of consumer it can deal with. I think a lot of traditional messaging system only deals with real-time consumption. If your consumption is not real-time, it doesn't perform as well. But with our system, we can power both the real-time as well as the offline pipeline. So in one pipeline, we'll have all the data loaded into Hadoop, our warehouse system, where we can process a lot of those data in batches. But the same data, if you want, you can feed into other systems. So we use the same pipeline to power our real-time search, real-time monitoring system, real-time graphing system, and a lot of those just ad hoc real-time applications. So that's sort of the benefit of using this central scalable hub. So what we have in this company is we just want to build upon this open source system by making the open source core free as a Apache project, but we want to productize a lot of things we build on top of Kafka and LinkedIn as a general as a general functionality, so that we can make the consumption and use of the open core Kafka more convenient. So that's what we're trying to build. So if you're interested in our company, I think you could go to confluent.io, where we will have a little bit more description on what we do, and there's a link if you want to talk a little more or just interested in opportunities in our company. Thanks.
我们已经很荣幸的邀请饶军1月份也在我们这个 Meetup 做一个关于Kafka 和 Containerization 的 TED Talk， 所以欢迎大家下次再过来参加。下面一个是我们请更多科技的 Chief Architect， 介绍一下他们公司。
大家好，我叫李振林，今天借这个机会来介绍给我们的公司 More Technology 做一个简单的广告。More Technology 是由2位南大的校友共同创办的。第一位是赵普，他是游喜集团的创始人，在10多年前创立了游喜集团，到现在呢，他经营的那个十元妈咪品牌占有超过95%的品牌孕妇服装市场。他也是高端企业创始人黑马会的那个首任会长。他同时也是南京大学在上海校友会会长。另一位呢是创始人是朱庆国，他也是来自于南大。他和本人在前几年创立了 Python Insight 公司，并且在前2年呢被 VMware 成功的收购。他是同样也是南京大学在硅谷的校友会会长。我们还有James Hong，作为我们的 COO， 他拥有丰富的经验。 他曾经是富士康的 VP，负责Apple 在富士康的所有生产业务。他还有其他硬件和管理的丰富经验。他同时现在也任美国绿城集团的Chairman，还有其他重要的职务。我们还有非常强大的研发团队。在硅谷，我们主要是放在Cloud Infrastructure 和Big Data 的研发。在上海呢，主要是 focus 在Front-end 和 Mobile 的。在深圳呢，我们还有 Smart Device 的 Hardware R&D。那我们公司的主要用户群体呢是针对孕妇。那为什么我们针对孕妇呢？因为这是一个巨大的市场，在中国每年有大概2000万的孕妇，而他们呢是有强大的购买欲，而且有很强大的购买力。因为整个家庭一旦有一个人怀孕，那所有的精力都会放在这个孕妇身上。在中国1、2线城市呢，大概每个孕妇的消费大概在1万人民币以上。那我们的用户他是有刚性需求的，譬如宝宝要有健康，出生的时候健康，怀孕的时候也要健康。妈妈呢要把身材在怀孕之前要备孕，在怀孕期间呢要进行体重管理，在产后呢要进行身体恢复和瘦身。他们需要有很多的需求，而我们呢拥有非常丰富的经验，因为我们的co-founder赵普在这个行业已经做了10几年，拥有了上千万的用户群已经。那我们的任务呢，主要是借助于母婴的健康设备作为切入点，利用大数据的技术，向特定的用户推送个性化的和立体化的健康服务。这张图呢，描述了我们的那个智能解决方案。我们研发了多个针对孕妇健康的智能设备。这些设备收集数据以后，我们会放到我们的云端进行大数据分析，然后我们向用户推送个性化的服务，而且我们和第三方譬如医院和健身俱乐部有合作，所以我们还提供了线下和线上的立体化服务。那现在我们还希望更多的牛人加入我们的核心团体。在湾区，我们希望招募一些拥有云技术Big Data Analysis 的经验的牛人。如果你们感兴趣的话，可以跟秦波或者我联系。秦波今天刚回上海，所以如果需要联系他的话，你可以发 email 给他。谢谢。
我们下一位，我们请Bordex Lab 的 co-founder 沈优华，大家做个简单的介绍。
谢谢，这个 Meetup 组织得非常好，挺喜欢这样的 setup。那个 Bordex 做的一件事是做这个跨境的这个电商，跨境的这个travel， 跨境的 mobile 上面是。因为在过去这将近4年中，我在中美之间 round trip 大概有接近50个，我是深深的感觉到，第一个就是中国的 consumer 需要这个更好的这种美国的这种product service， 而这个美国的这个 product 又想开拓到中国市场，但是他们由于种种原因而没有人很 easy 的 reach 这个 Chinese consumer， 所以这个里面是有 huge opportunity。所以 Bordex 的 mission 是 connect 这个mission 是 connect 这个 American brand with Chinese consumer。但这个听上去是我可能大家看的这个是跟代购啊或者什么有关。其实我们这个 culture 为什么是 lab 是一个 lab setting， 是其实我们希望的是一个其实希望的是一个这种innovation 的一个 environment。我们 create 这个 lab 这个 environment 是大家 innovate， 这里面其实有很多的在跨境的在 international 的 setting 上有很多有意思的问题。我们这个 team 大概现在在大概有10个人左右，在我们叫它 X man and X woman 这种 极有意思。大概这是我们这个 culture 是非常开放、非常开放的一个 culture， 非常透明的 culture。这是我们也经常组织一个 X Talk 啊，还有 X Micro Conference。这里面是我们2周前在我们的 Mountain View 的 office 组织的一个跨境的Micro Conf 微会。里面当时有这个跨境的，有这种e-commerce 跨境的这个travel 跨境的这个教育方面的人来参加了一些活动 ，share 这个我们在跨境中碰到的一些挑战，以及我们的一些 solution。这是我们的一个 office， 我们现在是 Sublease 人家的一个小 office， 大概这是我们的 kitchen area。大概我们现在大概在这个 office 是在 Mountain View 的 downtown 和在Sunnyvale 的 downtown 之间，在那个 Central 上面。我们现在需要的，我们大概现在需要的人才是无论我们 general 呢，我们需要非常 strong 的这个engineer product UI designer， 还有 marketing， 还有这个 business development， 还有 sales。我们现在特别需要的是这个 mobile developer 和这个特别是能独当一面的 mobile developer 和这个人在美国做 BD 和 sales 的 talents。这是我的这个，大家如果感兴趣可以，这是我的 WeChat 和这个大家可以扫一下或者加入我。如果我也会在这个 site 里面，如果大家对这个 BOLDX 做的事或者机会感兴趣，可以在这个会场 break 的时候或者线下的时候跟我交流。谢谢。
谢谢雪华。最后我们邀请Databricks 的 co-founder 跟他做一个
谢谢。
刚刚那个来的有点晚，因为我跑到另外一个 building 去了，那个 QD1 在可能某个3个 phone 上面写的那个，然后后来发现到那里还有其他人也跟我一样都走错了。我大概很快跟大家简单讲一下 Databricks 公司的一些情况，如果大家有那个对公司感兴趣，还有对 Spark 开源项目感兴趣的话，到时候可以聊一聊。就可以就是大家如果举一下手，如果你听说过这 Apache Spark 的话，可以举一下手。大概有差不多一半的人。先简单介绍一下我自己，我原来在 UC Berkeley AmLab 就是读博，然后大概在1年半前的时候离开了 Berkeley， 然后现在在 Databricks 公司其中一个创始人，主要 focus 在就是我们 Databricks 的 product engineering， 然后偶尔会做一些 open source 的相关的东西。Databricks 在1年半左右，去年5月底的时候成立的，然后现在是一个 Series B company， 大概有2轮融资，差不多接近50个 million， 有45个人的样子。然后最主要从 engineering 方面的2个function， 其中一个是引导的这个 Apache Spark 的开发，然后另外一方面是我们希望，我刚跑过来有点累。另外一方面是我们在通过参与 Spark 的开发的途中呢，其实跟很多不同公司、组织、机构都有联系，然后发现了在这个就是现在 Big Data 很火，但是真正要从 Big Data 中提取价值，整个 Data Pipeline 非常长，时间非常长，非常难这个真正的提取价值。然后我们希望提供一个好的平台，一个 Cloud-based 平台，让这个各种公司、组织、机构，让以前需要可能花1年或者2年的项目，现在可以在1-2天之内完成。然后简单介绍一下 Spark， 大概可能差不多有接近一半的人没有听过 Spark。Spark 是目前比较火，可能是其中一个最火的这个开源项目吧。主要针对这个大数据的 infrastructure， 是一个 computation framework， 主要基于 computation 这一块。然后 Spark 在最早的时候有这个 Spark Core Engine 是 Berkeley 一个叫 Mattia Zaharia， 现在是 MIT 一个教授的是我们公司 CTO 的PhD dissertation。然后这 Spark Core 其实提供了一个非常快，然后非常好的一个平台，在这个之上呢，你可以搭建不同的这个 computation pattern。然后我们在 Spark Core 之上做了非常多的不同 library， 比如说基于 SQL、Streaming、Machine Learning、Graph Computation， 然后甚至还有一些比如说现在 R 的 API， 还有 Proximate Query 之类的。这些很多传统上会有很多不同专业的，就专有 specialized engine 做的事情，比如说很多专门的 data warehouse 或 SQL。可能有专门的 machine learning 的 framework 或 machine learning 的 startup 做 machine learning 相关的东西。我们现在发现这些东西一旦你可以实现好在 Spark 之上，其实可以达到非常好的性能，然后还能可以提供非常好的一些曾经做不到的东西。简单的说 现在我们相信 Spark 可以作为一个 single engine， 可以在很大程度上满足可能90%到95%的不同的 data processing workload。这样很可能曾经你需要维护100个不同的系统，每个系统做一样专门针对某种 workload 做一个东西，现在可能只需要一个系统就够了。同时你只需要学习一套 API， 维护一个系统。然后甚至在某种意义上说，这可以提供很多过去做不到的应用。比如说打一个很简单的比方，在 smartphone 出来之前，你可能有个 GPS， 作为这个导航项目导航仪，然后可能有一个单反来拍照片，然后很可能有个专门的手机，然后另外一方但现在有多少人还会带着一个单反，随身带一个单反，加一个 GPS 导航仪，再加上一个手机，再加上一个相机？这样大家可以举一下手，如果还带这么多设备在你包里的话，那有多少人带着一个 smartphone？ 真有人不举手了，基本上。所以 smartphone 很可能在某一些领域，它甚至没有专业的设备好，比如说 GPS 导航，你 iPhone 上的导航可能远没有一个真正专业的 GPS 设备好，但是大家更倾向于利用就是带着一个简单短小的 smartphone 来满足绝大多数的应用，然后甚至因为所有的功能都集成到了 smartphone 上之后呢，你甚至带来了很多传统意义上已经做不成的东西，比如说你现在可以通过 iPhone 拍一张照片，直接 geotag， 然后在 Instagram 或者 Facebook 上传到网上，这些东西在过去在分开的系统、分开的这个工具里头是完全做不到的。那么现在我们也希望在 Spark 这个 ecosystem 里头通过更好的集成不同的这些 workload， 可以为大家大大的减少需要的这个 operational complexity， 在这个 data pipeline 上是做到很多以前做不到的东西。然后可能大家不知道的是 Spark 在我们的带领下，现在已经变成了目前从 contributor 上算最大的这个开源项目。在过去短1年里头，接近400个工程师在全球各地，包括很多在中国的人给 Spark 贡献了代码。然后有非常多的用户，包括大家熟悉的在美国公司，还有很多在中国的公司，包括 BAT 3大头，基本上都在用 Spark。腾讯甚至有个8800个节点的 Spark cluster。然后基于我时间不多了，我就不怎么讲了，剩下这2部分了。我觉得最后留讲一下 Databricks。我觉得现在是一个很好的机会，在创业还有在这个大数据方面，因为传统意义上来说，很多做这个 data infrastructure 的公司，比如说 IBM、Oracle 和这个做这个数据可视化和最终 UI 的公司其实分开的，然后他们中间有个非常简单的 protocol， 比如说 JDBC。于是这个其实限制了很多真正这些公司可以做到的事情，因为当你中间的 JDBC protocol 非常简单，你其实是受限于这个中间的 protocol， 你没有办法造成来实现，比如说后端和前端的这个 code design。我觉得现在基于这个 cloud-based 就是 software 的 platform 加上 cloud-based delivery， 其实现在这新型的创业公司有这么一个机会，可以同时来 design front-end 和 back-end， 可以绕过这些中间就是过度简单化的 protocol， 来同时 design front-end back-end， 做到一些可能以前所有这种大型公司包括可视化公司都做不到的事情。其中一个简单的例子就是 online aggregation。基于这个时间可能不多了，我建议大家可以看一下这个，就摄取一下 online aggregation 的 idea。我个人觉得非常酷的，我觉得非常有价值。但是在过去20年里头，没有一个公司可以真正的做到这个东西。尽管你一旦读完这篇论文之后，你应该会觉得为什么到现在还没有一个可行的方案呢？我觉得跟刚刚这一点是有关的。所以如果你对做更好的大数据相关的产品有兴趣的话，欢迎这个和我交流一下。
好，最后我来介绍一下今天的 presenter 栋成同学，他是跟我差不多时候报 Google 的，然后他一直在做 Bob 的东西。先讲一下 Kubernetes 吧，因为我觉得这个其实是一个 pain point， 是，不好意思就从 high level 的讲的话，它其实是一个 eternal 的一个 pain point， 长期以来，因为比如说现在你要做大数据，然后这个东西要 deploy， 很多时候你是要 deploy 到 enterprise 上去，那 enterprise 的话 比较难的是你整天搞一堆的人跑到各个公司去做各种各样的 deployment， 这是很痛苦的。然后 Kubernetes 其实它做了一个，就 Google 里面它以前有 Borg， 然后 Borg 的话它其实就做了一个 layer， 你以后的话就可以说好，你这套东西你在那提起来，提起来之后你可以远程的 deploy 东西。然后 Kubernetes 我很高兴看到 Google 把这个东西 open source 了，基本来说这是一个非常重要的一个变化。然后我很高兴请到以前 Borg team 的 Tech Lead 动成同学来讲这东西，他也刚好加入了 Kubernetes。好，
谢谢。我先那个就是在我开始 presentation 之前，OK。然后呢，我先道歉，就是那个小峰跟我说希望我能用中文讲，但是呢，我看到一些old friends， 他们以前可能在我跟他们交流的时候，我就跟他们说过，我说我以前是学数学的，学统计的，所以呢，所有的 computer science 的 concept 呢，我都是从英文来理解的，所以呢，我很难去用中文讲。我也可以，就是说一半中文一半英文，但是我觉得这样其实就是我一直就是我一直试图避免这件事情，因为在家里我想要只讲中文不讲英文，所以我可能待会儿 presentation 全部用英文。但是呢，就是你们可以提问题用中文和英文，如果我听不懂你的问题的话，我可以请他们翻译一下，好吧？然后我先自我介绍一下，然后自我介绍可以用中文。就是我加入 Google 在7年半以前，然后呢，当我加入的时候，我们是第一代的那个 Borg 就是 roll out， 然后所以 okay, so let me switch this one. So the only workload it is the batch workload, and there's no production services. So there's no real container. Container is just talking, and we try to push some kernel concept and to upstream, but it's just in paper. It's not really working. So my first job actually is to do the process tracking, figure out which process group should belong to which task, and then realize those processes based on to provide some CQ, and also we try to look at the prod file system to figure out memory usage and try to do the prod hoc enforcement. So anyway, so let me start my presentation. So okay, so how many you guys ever play with heard the Docker before? And how many you guys ever play with the Docker container? And it looks like quite a lot of people have understand the container in certain senses. Even you never heard of the Docker container, but at least at home you have the container, right? In your kitchen or whatever. It's kind of similar concept. So Google has been developing and using containers to management of application for over 10 years. So literally everything in Google is run in the container. So no matter what kind of all those Google services you ever heard, Gmail, web search, and all those maps all run in the container. And even like some infrastructure jobs for internal use run in the container, like the GFS Colossus. And to support the cloud, we even have, before that, and we also have the container run inside the container. And for now, we have to support the cloud, we have the virtual machine run inside the container. We have the container run inside the virtual machine and then inside a container. So it's nested. So just based on what kind of the performance and the QoS requirement, SLO, all those kind of things you ask for, so we compose those together. So I will get some detail in the next things. So why Google love containers so much? We've been in this area so long, and many times I attend the Linux Plumber conference. We talk about we need this feature for the C group, which is the Anthony's container technology for the resource management. So they just don't understand why. Why you want this one? This is just ridiculous. So the reason we so why we need the container? And because this is, first thing give us is better performance. To deploy a container compared to the deploy of virtual machines, it's much faster. And without much overhead, and save of some extra resource. And also, container provide, but when we first start container, it's not a good story. And there's isolation issues. Container by default, they interfere with each other. So without the extra technology we push to kernel, and you cannot achieve the isolation. But anyway, without the container, you also have like the process interfere each other. So we, over years, we try to, for example, you have the 3 jobs. Each one expected 1/3 of the resource on that node. If one of those like to container go crazy, and to take out of the extra 3 another 2, and what can do? The things happen without those extra stuff enforcement in the resource container. So over years, we first push like the CPU, C group things, and we try to make those resource sharing is more fair. And so we first start, we also push the first initial version of the memory enforcement. And based on the static partition of the memory, we call the fake UMA. And then we roll out the split hierarchy, so we can apply the different policy on the different resource based on their characteristics. And then later we go back to enforce the disk I/O bandwidth and network bandwidth. And at the end, we revisit memory. So if there's someone interested about memory, so we get rid of we are using the memory controller in the Linux upstream kernel and get rid of the fake UMA. And so this one, we get rid of the static partition on inside the kernel. So with all those kind of things, it's not free. Most of those tools we try to push to kernel upstream, and some is failed because they think about the complicated kernel. They don't understand the use cases. And but with those kernel, actually we achieved very decent isolation between the containers. Okay. So now another really good things about the container is the repeatability. And so think about the old time. When I give you a binary, without you just can run. You just get that binary because all is bundled. There's no extra dependency required for you to configure registry, all those kind of things, and the shared library you have to install, and the libc version, all those kind of things. So container actually help us to achieve that goal. And inside Docker container actually is doing this is really good. Once I give you Docker container image, you can run on even your laptop, your local machines, all the things. Google initially is not start with this one. We are using the signed bundle binary and signed bundle package. So, but I have the same actually achieved the same repeatability of this goal, and so it's kind of similar idea, but we think about the Docker's packaging solution is better than us. So we start this kind of the similar idea 2 years ago, and now we have the Docker. So we just reuse the Docker concept. Earlier I mentioned that container provide isolation, protect your task, protect your jobs, but think about once you have that one, and you have to enforce the limit, you want protection. So then there's the utilization issues. Because when if you have the product and services, you have to provision their jobs at your peak node. Right? So then, but the peak node is way more than your average node in most cases. So there always have the extra waste. How do you improve that? How do you improve utilization? That's based on my years experience, even like the long time ago, we talk in the Vertex, we talk about some data center. So the workload, the utilization of those data center actually is really extreme low. And when the first time Google tried to use in container, we have the really, really bad experience with the utilization. And so we waste a lot. And I forgot the data because that time it is a top secret. So I try to not remember. And I will disclose to some other people. So, but it's something like the 10% issue, something like that's really ridiculous. So a lot of people have the question, so can this container technology can go further? So then we introduce the quality of the services. We believe different services have a different requirement about the guarantees, different guarantees. So then to achieve that, we categorize the services into the 2 tiers. Tier 1, like the web search and like the Gmail, all those kind of things, user-facing, front-end things. And so those jobs we provision, we try to guarantee their performance. We provision them based on their peak usage. So then we have some like the backup support job, which they are very important, but their latency throughput requirement is not so high, like MapReduce. So then those tier 2 jobs try to using Slack resources from those machines. But they could yield when these tier 1 jobs ask for more resources, they always yield. So then we have like a set of the quality of the services defined for those different type of the jobs. So this is really helpful, improve our utilization, and also enforce the, actually help us to understand the services performance requirement and enforce that. So how do you achieve that? So you need better accounting, right? So if you say, oh, my services provision, I want to have, my peak usage is this. If you don't really have the accurate accounting, how can you achieve that? So even like for example, for Lightwork things, when you open a socket, your kernel there's the actual memory allocation in the kernel. Should you charge that to your root, your system daemon, or you should charge to user? So we try to enforce that, to always charge to user, because otherwise your available resource on a load is very relative, always changing. So you cannot predict how much your your services will require on the services perspective. So we did a lot of accounting and try to understand. Also, accounting help us to improve debuggabilities. Then you can understand why my job all of a sudden have the spike of usage, and then you can do better. And also, this give us the histogram of the resource usage, so we can enable more automation for our systems. So, and also we can detect there's the separate system can detect the lack of the resource. Then I need to add more node, more resource in my resource pools. So of course, then there are visibilities, right? I think I covered in some other things. So, okay, hopefully you feel container is important here, and container is so awesome. And I want to run all my application, everything in the container, because totally it is improve my productivities. So I want all my applications run the container. I want all my machines run the application within a containers. Here's the problem. There are so many containers there. How the back end. So if there's some container is provide functionality for some other front end containers, how those front end container can find back end container, and how you group them together, how you do management. Did you find there's a problem? And then we need a container orchestrator. And so that's the Kubernetes. So Kubernetes is one of the container orchestrators, and there's some effort. I think there's many other activities in the Docker world. So we initiated, we launched and the development and the chauffeur, the Kubernetes the Kubernetes in March, I think, this March. And since then, there's many startups, even Docker themselves try to provide the container management solution. So Kubernetes is a totally open source project, and pretty much entirely written in Go. Even our internal Google work and the next generation of the work, Omega, all written in C++. But to make this open source cluster management easy to adopt it by outside the world, so we actually re-implement those kind of things in Go. And because Docker is implementing Go, and there are CoreOS, all those kind of things implement Go. So we try to not make the Kubernetes locked down by the Google Cloud platform. So Kubernetes can run in the multiple cloud platform, and also can run on the bare metal machines. Even you can start the Kubernetes cluster on your local machines, your laptops. So we integrate with a couple startups, a couple companies, and include the Mesos, include the Docker, and also there's the people put on the CoreOS and Red Hat, all those partnership. And so I can see the Kubernetes actually is inspired and also really development based on our years experience on Google infrastructure. We learn a lot of hard lessons based on the years. So we try to avoid those problems when we develop Kubernetes. I will mention something later. But most powerful things I want to mention that we think by giving Kubernetes, and we are so what I would say, we separate the machine management, cluster management away from the application management. So a lot of people think about I want to deploy an application, like especially startup. They have to think about, okay, I have this application, I have this Redis master, Redis slash, and then how much resource I needed, and how many nodes I did, and how to configure, and how they connect to each other, and then beyond that, they will start there. Oh, how many replica I needed, and what's the node balance, all those kind of the things. Then you can start your application. So then the new version development, they want to deploy. They have to think about again and say, oh, how many releases I need management? And there's some people rely on the really old release. Maybe I need to recalculate my resource and how much. So Kubernetes actually makes sure application developer never worry about machines. And then cluster management people never worry about the applications. For you, everything is same. It's just container, and there's requirements. You just need to follow those rules. That's it. So one of the Kubernetes, my coworker working on the Kubernetes, he actually is the initiator of this Kubernetes. So he mentioned to me, he used to be web search guys in Google. And he used the company to me a lot because I'm the tech lead of one of the cluster management team. So he said, oh, you guys doing this, because he had no idea what we are doing. So he said, okay, you did enforce one of the SL, you guys promise. So, but he never worried about the machines. He never worried about the configurations of the machines. He only say, okay, here's my application. What is my throughput? What's my QoS? So then he just forced those information to me. So then I have to figure out where it is bottleneck it is. So Kubernetes, I have to try to solve those problems instead in Google. Okay. Before I get into detail, and here is the last picture some people draw, and in my team, and this is, you can see the happy face, smiling, that's the user, hopefully. We can give the user like this impression, and then we do nothing, we just create the pod. And I will explain pods, what is pods later. And so then submit, they just say, oh, here's my requirement about the pods, there's the desired state. And the API server actually is our master to receive those requests and then allocate those pods onto the Kubernetes. Kubernetes is a worker running on each node, and then they just start those and inform those things. Before I get into the detail, and I want to talk about the primary abstraction we Kubernetes tried to introduce to the cluster management world. So there's something is different or deviated from the Docker. So one thing is not container. So it's just still the application package. Just Docker container currently we support. But we could support other container too. So then there's the pod. Pod is just a small group of the tight coupled containers. Because we always feel the pod is the smallest things we want to manage in our cluster. And you could have the pod with the one container, But we feel a lot of cases, a lot of things the application want to break out as the several separate helper. So those want to run separate containers because they have the different requirement. For example, in Google, we have like the web search, web services jobs. And they also have the logging. Logging want to break out as the separate process and management those web services. So we want them run in a separate container. So we have the different rules, especially resource management enforcement for them. So another example listed here, it is the content syncer. So you have the content syncer container, try to always to sync from some resource and about your content and save in some like warning or storage, persistent storage. And then you have the user front end web server try to serve users' request. So you want those is separate. And when there's more requests come in, and you may want to allocate more resource for web server. And then if there's no request coming, you may want to make the content syncer work harder and use more resource to sync and those kind of things. Okay, so then we have the concept. Another concept is called controller. Controller is simple. It's just loop. Try to look at what you desire. What's the user desire state, and then I always try to repeatedly try to move parts of my system to meet, to figure out the system's current state, and then try to do something, take some action to meet your desired state. So that's very simple. So one of our example I will talk about is replication controller later for detail. So we already have the replication controller, and we already have the node controller. And we are talking about the job controller. So then another concept is service. Service is also simple. It's just a set of running parts that working together. So you can say, oh, I want this like the super data group by it's dynamic group, and I will mention later. And so the base dynamic group based on the query. And then also apply some like the access policy. The current access policy, we only support is load balance, and also is round robin load balance policy. But all those kind of things could be extended easily. And then there's another very simple concept, but very powerful. It is labels. And labels is just identifier for the metadata to identify all the given objects and like parts, like the controller, like service. You need the labels as part of the metadata and attached to, and so you can do the query. So the query selector is just simple query based on the label. I will get into the detail later. Before I get to all those primary concept in detail, I want to say why we design like this way. There's the design principle. A lot of things actually is the really hard lesson we learn when we develop the board. So first thing I want to mention is the declarative. So Borg is not declarative, it's imperative. I specifically tell you, I want you start a task. I want you install a package. I want you do something for me. And but this is hard. When something's, I want to increase my replica, and or maybe there's something bad thing happen, and one of my replica get lost. I have no idea what's going on. So then I have to. There's the actual complex control loop to identify those problems. Then I can have to fix it. Then send a lot of imperative operations to fix those problems.
It's a Google condenser.
Because
somebody is on recording. Somebody is on recording the.
It's okay, but I'm not sure I can share the slides. But I think the videos could be distributed, so no problem.
Okay.
So Kubernetes is open source, and also this is based on the Google's templates. So whatever. So whatever you base on Google templates, that's the Google confidential. And I already got VP approval about this talk, so don't worry. And also I share the slides with VP, so he even have the comment. So. But I don't think I can share slides since they already mentioned the Google content ratios, but I think the video should be okay. So, okay. So back to the declarative. Can I have water? Sorry. Declarative API. So we think about the declarative API is very, very powerful. So you have the clear mind when the user started their services. They said, okay, what's my desired state? How many replica I want? And for each replica, what kind of resource requirement? What kind of things I want to start? And what's the restart policy? And for image policy, how often I want to sync my image? All those kind of things, when you start your services or start your replica controller, you can tell us. So then there's the loop, control loop reconciler, observe those changes, your desired state change, and query about the current state, and then try to reconcile to meet your desired state. So then your current state can go back. You can have the problem. That's okay. So there's the control loop, try to always match those two. And then another thing is modularity. Modularity and internal, so then we have like the clear component. Each one have the clear interface for each component. And also for the interface, we have the RESTful interface defined for each component. And so then with this support, you can you can either develop new plugin, so you can integrate Kubernetes, especially core Kubernetes, into whatever environment you want to support. And another thing is legacy compatible. So we learn this is in the hard way. After we develop work, like what I said, okay, imperative API and many problems, we developed Omega. Omega is good, cool, and declarative API, but we cannot deploy it. Why? Because it was legacy compatible. So we need to solve that problem first to roll out the Omega. So that's why we learned this lesson. So when we start Kubernetes, we first thing try to solve most tough problem is the versioning and how we are going to upgrade. So currently we are doing the V1 Beta 3 upgrading about the API report. So we try to exercise our power. Can we do those compatible support, all those kind of things. So, and also we believe the IP address is cheap. And so all the objects, I'm lying here, and we believe like all the pod, all the services can have their own IP address. So I will cover that later. And another thing is another things we try to avoid static grouping. And low grouping actually here is 9, and we have the dynamic grouping technology through the label query. So I will cover those things later. Okay, so go back to control loops. Earlier mentioned that we want to design state. You upfront to clearly to state what's your desired state. So then we have the control loop. Control loop is not a single control loop. You can add your own control loop into this whole system. So right now we have the replica controller control loop, and we are discussing about the job controller control loop, and there's the node controller control loop. So they all act independently on top of by query our master API server and understand our current state of the system, and then try to, based on the current state and based on the desired state, and try to drive the current state to meet the desired state. So we try very hard in the API now to add the shortcuts, which it is like there's some emergency coming. Can we add one important operations to say, shut down this pod because otherwise there's a sysboom and something will blow up. No, everything goes through the desired state. So later I will cover how we solve those problems. So in this cases, your current state is the truth, is the real only truth, and so which can go back, but we try to fix those problems, reconcile by those. Okay. So next I cover this one is modularity. So modularity is the whole system, all the components loose coupled. And so then everything can be simple, everything can be tested separately, and internally right now, even internally, actually those kind of things is being examined, and we found this is much easier to evolve and to extend. Like for example, in Kubernetes, we have like the plugins. We have the wallet plugin at node level. We have like the controller plugin at the on top of the master level. So you have the then we have like the scheduler, different scheduler. Currently we only support one scheduler. Node-based scheduler, but you can plug into your own product and services scheduler. You can plug into your own batch workload scheduler because they all have the different rules and based on the different requirements. So this is really powerful things. But to really achieve that, you need atomic storage. So atomic storage is just help us to separate the state from your control loop, from your service. So then you can have the stateless. So then you can achieve the scalability. So this is kind of the for the distributed computing, this is really powerful things. And also for this storage, we have the watchable API. So currently we are just using the core as etcd and as our atomic storage. And so many people, the Google knows the Chubby. Actually, the core is etcd is inspired by the Chubby document. So pretty much, I think a lot of people are familiar with this kind of things. So labels, very simple concept. It's just key value pair, and to be all the in the earlier slides I mentioned that some like the API object like pod, service, controller, and all those have associated label set of the metadata. So then you can give arbitrary labels, and the label can be overlap between your objects. And so how you're going to use that labels? You're using label can be query. So you can just think about the query. It's kind of like the circle statement. Select something while something equal to something and something equal to something. Those kind of things. So you got a set of the dynamic, the set of groups. So this is the only group mechanism supported by Kubernetes. And so then we have the controller, we have the services, all based on this grouping technology. So think about this, how powerful. So in most traditional cluster management, you are doing the grouping. You are saying, okay, this set of services, or this set of node, this set of jobs to do this, to, like for example, do the canary release. And in this set, another set of things you have to do the production. So you have to maintain that static grouping. Right? You have to make sure there's never go back. If there go back, then you got an alert, wake you up at 3 o'clock a.m., something like that. So with this one, so you can go back. And then there's the control loop monitor and always keep query. Give you dynamic group set of the objects. If it's not meet that set of the objects not meet your desired state. Like for example, I want 3 replica here, and I just try to drive in my replica number to the 3. If the one of these go bad, if I need more and I found I need more, and then I just add 1. If I found I have too many, and I just kill 1. Just as simple as that. So now I give you one example about the selector. So you can see I have the 4 pod. Each one have attached by some like the label sets. And all they have like a label set called application equals Lifty. I have no idea what Lifty is. Someone come up with this as example. And then some have the face as label, keyword, and then have the row. So now I want to figure out how many, I want to have a group of application or pods run the lifting. So now here it is my group. And then I want a selector. I create a selector. I want to have the application lifted, but it's the front end jobs. So I got the front end jobs. Have the 2 return. And then now I have the back end. So now I have like I want to hold lift services, and it's in the development stage, development phase. You got 2 pod here. Then there's the testing phase. So now we are talking about pods. Pods is the first atomic concept in the Kubernetes. So it's the smallest unit we want to manage in Kubernetes. So the pod is simple. It's just couple the container together, and they should deploy together, should be scheduled together, they should be restarted together. They have the same policy applied to each other, and they share the same namespace, especially for the network namespace. So pod have the IP. Each pod have the unique IP, and so even you have like this 2 pod, each pod inside the container have the 2 container have the same ports. They won't conflict each other because each pod have their own IP, even they are scheduled on the same host. So pod is the ephemeral. They can come and gone, and then the controller will replace that, and will find those things. So there's the one example I draw here, and we have like the 2 container. One is the data pooler, one is web server, and they all share the same volume, and then try to working together. So okay. So pod network. Sorry. This part, network part is the which we are trying to deviate from the Docker network model. So each pod we have the IP per pod, and which is they have like a unique IP in a flat shared network namespace. So all the pod, no matter you are on the same host or not in the same host, you can ping each other, got the full connection. This is different from the Docker. Docker has the private IP. So then you have to complicate, create some extra step and link, all those kind of things, and then you can access the different pod in a different node, all those kind of things. So we try to change this one. So this is the fundamental requirement for Kubernetes. So you can see from here, I draw that one. You can see that each node have their unique subset. And then when the pod schedule on each node, they get the unique IP address within that subnet, and then they can connect to each other. And so here's the one. So one is have the same life cycle as the pod itself. When pod destroyed and removed, and one is removed. But that doesn't mean okay, your data is removed. And so we can't support several type of the warnings, like an empty directory by default I will give to you, and so you can use that for your login and all your work data. And then we also mount, similar like the Docker warning, we can have mount the host file and the directory. So recently I added like the application termination log as one hidden warning for all the containers. So we can capture your application termination regions if you write something like the okay, I crash and why I crash, so you can get this information. So then we have the Google persistent disk. So I mentioned that earlier, one can be destroyed because they have the same life cycle as the pod. But your data not will lost. Because your data, if your data is living on the Google GCE persistent disk, so then you can recreate that warning and map to your create warning mapping to your GCE persistent disk, and then you can assign that warning to your pod again. So then your all container can access the same warnings again. So So we can have more volume to support. There's many things, like one thing in here is the Git repository volume, and so still is in the debate. So if you guys have the more thoughts about volume support, and you can file issues to us. Okay, here is the one example of the controller, replication controller. This is the canonical example of the control loop. This is the only mature control loop we currently support at this moment. So this control loop run as the separate process. Currently it's on the same master node, but it's not the same process. And so this controller only have the one job, just ensure number of the replica the user desired to meet. And if there's not many, is to fail, then we just start new ones. And if the too many, then we kill something. So this is very simple things. I give you some example later. Okay, here is the one simple example. I have the 4 node of cluster, and each node they have like the one pod instance running, because I have the desired state, the number of the replica is full, and my current state it is full, so I match my desired state, so do nothing. So something bad happen, and one of the node and have the trouble, have the network competition, whatever the reason, so I cannot reach my node 2. So now my current state, when the replication controller try to query the system, they found a current state. My replica number it is only 3. So what we should do? So I have to start 1, and then they just told I have to start 1 and tell the scheduler bound another replica on the node 3. So now you have your number of the replica equal to 4 again. So now the network partition issue is gone, and then node 2 is connect to the cluster again. So now I found, okay, I have too many, I have 5. What I have to do? I kill 1. Just as simple as this. Okay, service. Earlier I mentioned that each pod have the IP, and but the problem is pod can be gone. Pod is infinite. So every pod have the IP, but we cannot rely on those, right? So what can we do? If there's a group of the back-end jobs try to provide the functionality for another set of group of jobs called the front end, and how they find each other, so we introduce services. So services actually is just a group of the pods, acts at 1, and how we group them just based on the selector, which it is based on a set of labels we defined, we assign to the pods. So, and also services have to define access policy and how we access those pods in the back end. And access policy currently, I think I mentioned earlier, and it's only supported load balance, but there's the more policy coming and could be plugged into the system. So services give to the client. What does service give to the client? It's just one virtual IP and a port. So it's simple as that. The IP here is different from the IP we assign to the pod, because that has a fixed destination. So pod instance, each given pod instance has a fixed IP address. So using that IP address, you are really reach that pod. But here it's different. So I think I can. This one maybe have a better picture. And so when the client creates a services, so we are using the IP table, Linux IP tables, and so we give you, so you can create a services. They have like the IP address 10.0.0.1 and the port 9.3, 9376, all those kind of things. You maintain that map, and when we start services, and on each node, and on each node they have the Kubel proxy, services proxy. And so they will watch, that proxy will watch master, And so we say, oh, there's the services creation or services removing. When the service is created, so they will keep maintain the services name to a list of the IP address. That list of my IP address will be the pod IP address. So you create that routing table. And in the IP tables, that maintain another map, which it is services to a list of my Kubo proxy IP address. So you have that two routing tables here. And then we just redirect when the traffic comes and redirect to proper IP, proper pod IP. Did I talk too fast? Okay. So pod. So again, pod is the honestly when we talk about the Kubernetes, and my coworker and I will keep talking about those kind of things, we think the most important concept is pod. And if you think about the core Kubernetes, the only concept we want to give to people is pod. And so in this case, pod lifecycle is quite important. So pod is in form of can come and gone, and who maintain those kind of things is replication controller. And the pod have the state pending because I haven't started all the containers not running in the running state. The pod is pending. So you could put in the image, download the package. You could be waiting for scheduling, all those kind of things. So then all those containers in the pod succeed or finish without error, then that's the succeed state. And otherwise, if something went wrong, there's the failed state. And the restart policy, we have the restart policy to determine how we are decided this is failed state or not failed state, and then we have the controller loop to decide how we are going to do when this is in the failed state. So I think I talked about those things. Okay. So Google just recently launched the Google Container Engine, also called GKE, and it's kind of the host Kubernetes solution, backed up by Google Compute Engine, and so have the better integration, have the better network, all those kind of things support. But we also promise we never lock down the Kubernetes, so you can embed Kubernetes in the different cloud platform. And if you are interested, we have like the roadmap, and we just recently have the Kubernetes Contribute conference in Seattle. And so we redefined our roadmap, and we expected we have the production release. I think right now we just released the 0.6, I think last week. And so sometimes in Q1 we want to have like production release, 1.0 release. And so this is open source. So we want your help. If you go to the Kubernetes GitHub, and you can see a lot of issues have a label called help. And so you can pick up those kind of things. And also if you play with the Kubernetes and you found an issue, we have the IRC. You can through the question, or you can send an email to the Google Containers whatever the group. And we have the on-call people. Actually, yesterday I'm on call. And so you can help us file the bugs and help fix some issues and start discussing. So, okay, so thank you for listening to me. Blah, blah, blah. Any question?
Yes. 我的问题有点多哈，一开始确认一下，一个是在用 Kubernetes 的时候，每个 Docker container 里是不是通常就 run 一个程序啊？就是 container 是不是被用来做 packaging？
不一定啊，你也可以我曾经做过，我有在那个 Docker container 里面 run 一个 supervisor 里。然后呢，通过 supervisor start several applications。
所以
并不是。
我的问题其实想说，如果典型的用法，是不是应该尽量
让每个 Docker container 里就跑一个程序。
是的。
OK。
因为否则的话因为这就是我们我们 we try to push 不好意思，因为我不要写那个 we try to push pod concept to Docker, and but not succeed. And so the reason it is, I think I mentioned that earlier in the container technology, in the earlier stage, because they have the different policy, they have the different rules, how you enforce for each application's QoS and their resource requirement, and also dynamic the config things. You want each container run one application, that's the best thing.
OK。然后那个每个 service 里是不是然后一个 pod 里面是不是通常就一个 container image?
No, you can have a pod can just only one container image, or you can have 10 container image.
我还是问那个典型的用法里，一个 pod 是不是就 run 一个
？Inside Google, actually we don't have we don't call pod. We give the different name, but normally we have like if I remember correctly, some people did some kind. Maybe Liao can answer this question. He used to be focused on where you are.
一般典型的话是，比如说你有 binary 有 package 对吧？然后你有 data 的 package， 然后 data 的 package 有各种各样的，你会 depend on 你的不同的方式来 do package， 所以你一个 container 你是可以有不同的 package 的。这个我觉得这是常见的，经常会这
样。其实我也是 ex-Googler， 所以有时候，我听见大家讨论的时候会把 packaging 和 container 这两个词混用。
Yeah, I think that's different. Yes. You are right.
我理解，其实 container 做的比 packaging 多了一些。
是的。是的。
那个，其实我刚刚那两个问题的前提是我有点好奇，就是为什么 Kubernetes 基于这个 container Docker container 来做，而不是更简单一点，就直接基于 C-group 这样的系统调用来做呢？
我不知道你原来在 Google 是哪一个组的，就是我自己的 experience， 因为我是做 custom management 的，对吧？当我们每次有 product image， 我相信你 familiar with this upgrade， 还有 kernel upgrade， 我们其实都是一个 pain， 然后我们可能它会 affect our packaging which to support running tasks. With this Docker, actually Docker have the get rid of all those kind of self-dependencies and give you a single package. So then you can have the multiple on a single node based on the versioning, and you can have multiple version of the same package. And if there's the Google now working with the Java application, they will totally understand what I'm talking about. Because there's some old Java application depend on old version of the JRE, but the machines sometimes be deprecated, so they have to include those packages in their jobs. That's a really painful situation.
明白了。
Actually, internally we already started doing Docker image technology. It's just since the Docker already did, so we just.
就是更彻底的一种 packaging.
Exactly. To resolve this dependency, bundling dependency at the early stage, we try to avoid because we have the static building, all those kind of things, static build or binary, all those kind of things, but still is not completely resolve this.
我在有几个朋友的一些刚初建的公司已经开始在Google Compute Engine 上试用 Kubernetes。那有一个比较现实的问题是，如果用 Scala 或者 Java 来写程序的话，每个 container 里要装一个 JVM， 所以大家会想这事儿好像让我们这个每个月结账的时候心里更疼一点。
是 Java 是有这个问题，对。但是我们其实 internal 有，怎么讲呢？我刚才提到有一个 host solution。If host solution 的话，available， 当然我不知道是 current status。然后呢，如果这个的话，其实你就不需要每一个 VM 里面装一个 JVM，it could be shareable.
OK.
Those kind of things.
然后这个大概啥时候能？
我刚才已经说了，我说我不知道他们的 status。 虽然跟我们非常 close， 但是因为我现在转到 open source 去了，所以我没有太那个 follow 这个。
明白。
但是我们其实some people, especially core team and cluster management team, actively work on this things.
好消息。那我们还是 keep hiring Go programmers。还有一段我没有太听明白的是，刚才讲到routing 就是 IP address table 那一段。IP address table 是谁来负责维护呢 ？Kubernetes 负责维护这些吗
？By default, GCE already have those support embedded. 然后我们也 integrate with CoreOS。CoreOS 的话，他们也有一个他们的一个 tools round robin about the Kubernetes， 然后他们去维护这些东西。然后不同的 cloud platform have 不同的 plugin solution to do this kind of things。但是 again, GCE already have those things, we just reuse。
明白了，反正现在 GCE 好像也比 AWS 便宜一些。
是的。
降了一次价。最后一个问题，我关注到 Mesosphere 在折腾一个 Kubernetes on Mesos 这样一个项目。
对。
他们的目的是什么呢？是维持 Mesos 的一个 cluster 有若干可以 run 若干个这个 framework，Kubernetes 是其中之一吗
？Mesos 我想这里肯定有 Mesos expert 吧。
太好了，那好，线下的，不好意思，占用大家好多时间，我问了好多问题，谢谢。
就 Mesos， 我先回答你一个这个问题，我 based on 我知道的，我们其实跟 Mesos 是在 integrate 在一起。你刚才听到我谈了很多，其实 Borg， 我一开始如果不是小芳提到了 Borg， 我实际上不太想提 Borg 的，为什么呢？因为 Borg 是一个 process 的 scheduler，of course beyond the Borg there have many other things and 但是呢，Kubernetes 我们为什么要 start 这个 open source project？Actually we want to have the standard for cluster management API. So the pod, service, labels, always the API perspective. We think about that we want to support, and in the future cluster management. 所以呢，我们 of course we provide the scheduler to really allocate those container or pods on the different machines. 但是那只是 one kind of scheduler. So that's why we talk about composable plug-in. And so you can, so Mesos provide actually process scheduler integrated with Kubernetes using Kubernetes concepts. 这个，但是我们之间就是 I can think about one situation, help each other and move forward and try to finalize this industry standards.
明白了，就是听起来技术上来说，这两个项目是可以你中有我，也可以我中有你。
是的，希望是这样。
我觉得有点关系有点复杂。
是的，是这样，是这样。
比较暧昧。
还有谁有问题？
我问题是你对于 Rocket 和 Docker 的 fork 有什么评价？
对
Docker 那个 CoreOS fork Docker。
我们跟他们有合作，我不可以随便乱评价，因为都是 partner。但是肯定是我们跟 CoreOS， 我们用了 CoreOS 的很多东西 ，Flannel for the network support。And 我们用了它的 etcd as our storage, right? Back-end storage to store our truth of the master states. 我们跟 CoreOS 有非常好的 relationship， 然后我们最近才刚刚跟他们开会，然后我们 try to push CoreOS 最近也 publish 了一个 resource container 的一个 tool。我不知道有多少人听说过 Google 有一个 open source 的 native container for you。然后是 written in C++ 的，我们 push 那个东西曾经到过 Docker， 然后后来 Docker based on that interface implement libl container， 然后 CoreOS 最近也 publish 了 their own version， 我忘掉它的名字是什么了。然后我们可能下个星期会再 meet 他们 to talk about more about to support the native container for you， like container resource container layers API。所以我们是非常 tight 的 relationship。Docker 呢， 就像我说的，我们用了 Docker container as our image packaging solution 来，然后但是呢，有一些 Docker 跟我们不是很 match 的，比如说我们想要 push pod concept to Docker， 然后我们也想要 push 我们的 network model to Docker， 我们并没有成功。然后还有一点呢是，所以我刚才 talk 了很多这些东西，是希望就是说这是我们的 concept。还有一个东西是，Docker 现在也在做他们的container orchestrator， 但是呢，他们是就是 give you a cluster，you can think about just a single node，instead think about application，you are still think about machine. Here is the single node, and but actually behind the single node there's many physical nodes. 所以我们觉得，这是我 personal 的 opinion， 不代表中国啊，不代表民主。就是我们觉得这个 concept 是 wrong concept， 所以我们一直在 push 我们的 concept。当然最好是就是这些东西都能够 push down to kernel。Just like when we do the C group support, we push a lot of things to the upstream kernel.
所以如果我能总结一下你的个人理解，不代表 Google 官方立场是 Docker 作为一个 single container 的就是 management imaging format。你是比较支持的，但是有很多就是在 orchestration cluster management 方面的缺陷在里面。
谢谢。还有。
你好，谢谢你的演讲。然后我有关于 networking 的问题，我想问现在 Kubernetes 的在 pod 之间或者 service 之间的connection 是怎么 establish 的？
Services 和我刚才提到了有一个 slides 提到了一点点，可能还不够。就是当你 create a services 的时候，so 我们有在每一个 node 里面有一个 proxy， 叫 services proxy， 它能 watch 这个 master 关于这个 services 的 creation。And 还有这个 services 当它 created it is there's the endpoint. Endpoint is very simple. It is just IP address and port of the pods. 所以当它发现这些东西的时候，它就 update 它的 map， 它就 maintain this is map. And so and also when you create the services, I give you a virtual IP. And so the virtual IP and a port for your services. So then there's the IP tables maintained at routing and that things, and then those things will map to the host IP address. So once you reach that host IP address, then there's the proxy to maintain mapping from the services to a list of the pod IP address. 所以，但是你会发现这显然有一个 drawback， 因为当我想要 access a services for a new pod。Like I have the front end, I want to access the back end. I have to schedule those services. I have to schedule those pods first and create that services. Then I can get the new pod to access, talk to. So we are trying to get the Sky DNS in. So once we have the DNS, and then they can like the discovery, and then you don't need to have this problem.
还有一个问题是，你们有没有想过要再加一个 networking controller， 或者然后用一些 OpenFlow 这样的方式来做一些 software defined networking 或者 network function virtualization？
有，我们有 kernel people. Actually, our kernel people also can start to support open source Kubernetes. 我们有 kernel people working on those kind of things, and we also have like the one guy dedicated to talk about what's that called? There's the one startup, I forgot. And we talk to those people who have those network control group things. And we also talk about CoreOS, Flannel, and all those kind of things. So if you have some like a good suggestion, you can just send us email and file issues, all those kind of things.
好，谢谢，希望能听到这方面更多信息。
谢谢。
还有谁有问题？
非常感谢这个很好的演讲。就是说，我有一个关于 networking 方面的 说到就是说前面一张 slide 讲到就是说你们想 differentiate from 那个 Docker， 就是说你们要 routable 的 IP instead of private IP。然后还有一个 slide 是说这个 IP address is cheap， 但是在你的例子里面现在都用的是 IPv4 的这个 address，which is not cheap at all。所以说我就想问一下，
我说的是因为 IP address 会 change， 是因为 pod life cycle。Pod could be come and gone. Each pod have their own IP address. When the pod is gone, think about it. So when I allocate a pod on the node 1, so each node have the unique subnet, right? So then you allocate the pod IP base within that subnet. So now one node is gone. So you have the repo controller try to meet your desired state and start a new pod on another node which is in the different subnet. So you have the different IP.
所以说就是 IP 其实
所以 pod IP actually is not reliable. So you have the 3 replica of the pod, for example, and then one pod instance disappear, and then the scheduler schedule another pod instance to different node within the different subnet. So then you will get new IP. So you have to update your mapping table in that, in both, so in here. So you have to update that kind of thing. So which host I have that your services provide. And then you have like in your Kubo proxy, you have to update on that new node added. And say, oh, I have the new pod which have this IP address and to support these services.
所以在这种情况下，如果你 IP address 已经相对于这个 container 改的话，那你这个 DNS server 的那个 cache 也要 clean 掉。这 otherwise 你的 service 就是。是的，是的，是。对，还有一个就是在这种情况下，比如说你的这个 pod 的 allocated 到另外一个 subnet 的话，你这个 MAC 会有影响吗？就是说这个就是 MAC address。
为什么我的 MAC address 会有影响？我并不 care MAC。对我来说，我并不 care 那个 which machine run my pods。
OK， 就是说，那你们现在什么不 support IPv6 的这个 address？
对，是的，我们有 kernel patch to， 是的，我们 talk about IPv6。但是呢 unfortunately today GCE 当然就 support IPv6. So Kubernetes actually want to support IPv6. Just in a short answer, we want to. And also even in internal Google, we want to support IP address. We are transitioning to the IPv6.
OK， 所以我自己来问一个问题吧。那个就比如说我们 Google 里面的话，那个我们用车米对吧？你一个 port 一个机器，然后比如它挂掉的话，另外一个机器起起来，然后呢，它会注册到车米去，然后你通过车米 lookup 就可以看到。然后因为，但是你这里是 Kubernetes proxy 是做这个事情吗？还是因为我不是很明白。就比如说你的一个 port， 你刚刚说你的一个 port 是，比如说它淡了之后再起起来的话，它是另外一个 port。那它的 port， 它的 IP address 和它的 port 应该都换掉。
我忘掉提到了一点。为什么我们要 introduce the IP per pod？ 我们就是不想要 one of the reasons. Of course, there are many reasons. So one of the reasons we want to get rid of the dynamic port allocation. We want to get rid of both dynamic port allocation completed. In Google org, we are doing the dynamic port allocation.
Yes.
So some services they want static port access. So then you have to solve that port conflict at the scheduling level, right? And so the most services actually you don't need the static port because you could have the dynamic port. Then you have to publish in somewhere, and then you have to query, and if my job is done, and then I reschedule to another machine, so then I have to open new port, and then I have to update my registry, and then figure out that's actually a kind of the worm we want to get rid of. That's why in Omega we already talk about the IP per task, IP per S unit, and Unfortunately, we never can reach that because Amazon like Lexi support the compatibility, all this kind of crazy stuff. And so, but within the IP per pod, we solve this problem. Because when you schedule your container, you can say, oh, my container bounded to 80, port 80. And no matter which node you are scheduled, maybe you have the two same pod instance to schedule on the same port. They all have the container bound to using the port 80. You can do that. The reason is because per pod has a different unique IP address. So you access your pod through the pod IP address and 80, port 80. So you don't need to worry about the port allocation. So we never do the direct port allocation. I think I roughly mentioned that, but I didn't make that clear earlier. Hope I answered your question. Sounds like not.
我知道你意思，但是我只是觉得技术上它怎么实现，这个技术上我觉得挺难做的，就是你要保证一个 pod 它就是 keep 一个，就技术上它怎么做呢？
所以其实 Docker 其实已经有一个 port mapping, right? Even Docker say, okay, I have the container, and then I could specify host port and container port.
那 etcd 在 Kubernetes 里面是做什么事情呢？如果不是做这事 ，etcd。
你说那个 CoreOS 的吗？
它好像是一个 distribution。
主要是我们的 storage to back up our. So you must have heard of Omega persistence though.
No, I have no idea about Omega because I don't use it.
Okay. So it's just kind of storage and save all the whole master states. 所以呢，你可以 on top of that, you can always query what my current state it is.
我把时间留别人吗？还有人问吗？
你们support AWS 吗？
我有，如果你去看的话，你会看到有 AWS 的 support 的一个 directory， 但是呢，到底到什么 stage， 我其实并不清楚。然后我只知道可以 start Kubernetes cluster on AWS， 然后呢有 issue come in, so which means must be there's the cluster running somewhere on top of AWS。还有我不知道你知道不知道 Docker 其实已经 also announced the integration with the AWS something like that。
好 ，OK， 好像应该差不多，因为今天这个东西好像比较复杂，我都有点听不大明白。因为有很多概念其实还是挺颠覆的，
可能我应该做一个 demo 比较好。
demo 可能也不解决这个问题，因为我自己 install 过 Kubernetes node， 然后 install 起来，我自己可以看到，然后可以，但是我还是不是很那么明白那个 pod 的这个概念。
我们有一个 Google 的那个 Google Containers mailing list， 如果有问题的话 ，follow up 问题的话可以 send email， 还有可以 file issues， 然后 file issues 呢，正好我如果 on call 的话，可能就算我不 on call 的话，他们可能如果你们 mention 这个 tag talk 的话，他们可能就会直接 CC 给我，然后 I will try to answer all the questions。
OK， 好，多谢。那我们今天的 talk 就这样，那后面的时间我们应该还可以有半个小时，大家可以在这搜索一下。
就是不好意思，我本来想要带那个 Kubernetes 的那个 T-shirt， 但是没有了，还在 order， 所以我带了一些 sticker。
好，然后大家可以在这边搜索个半个小时，因为。